Okay, let's work on Enrico. Okay, so you have 15.
Okay. So my name is Enrico, and this paper is done with my professor Henry Chen, and PhD student Hideki Kyono in Kyoto University. Okay, so this is my talk plan. So first I will quickly review on some conformal blocks. And the second is some correlators and the anti-de-Sitter space. So this paper is about ADS CFT. So I will explain it. And the third is I will explain the meaning of geodesic Witten diagram. This is some kinetic object we can calculate in the ADS space. And this is done with in our paper. And finally, is the main point of this paper is we done the spinning geodesic Witten diagrams. Okay, so we know in a D dimension we usually concern correlators involving primary operators. So we know the conformal symmetry can fix the primary operators for 2 and 3 point functions. So the first non-trivial case is 4-point function. So the 4-point function can be fixed by this kind of forms, but these f, u, and v are conformal cross ratios. So you can easily check this u and v is fixed by the conformal symmetry. So the main ingredient is usually we use the conformal partial waves to expand this f, u, and v into this. So this G called conformal blocks. So this lambda 120 and the lambda 340 is the OB coefficient. So now the scalar conformal blocks we know that it will satisfy the Casimir equation. So this is PDE, and for even dimension conformal blocks can be explained into hypergeometric functions. So, but the other important thing is the conformal partial wave has the integral representation. So this integral representation is very important because it can connect the 4-point function, the left-hand side for the 4-point function, this W, and it can be explained into the two grouping of the 3-point functions. And one has the scaling dimension h plus I nu, and this nu is the real number. And this k can be k tilde can be computed. So now we talk about the famous ADS CFT. So the ADS CFT conjecture say the CFT in D dimension has the dual gravity theory in ADS space, but the dimension is greater higher one, so it's D plus 1 dimension. So for example, in the string theory, usually we call the n equals to 4 super Yang-Mills is due to the type 2B string theories and ADS5 cross S5. So there are two main, in large N CFT, the primary contains two parts. One is called the single trace, one is called the double trace. And this scaling dimension contains delta 1 plus delta I plus delta j, and these two are plus j. So now we know the 4-point correlators contains these two parts. And the other ingredient in the CFT is the spinning primary. So because we want to compute the 3-point function easily, so we need to use the embedding formalism. So we know the conformal group in D dimension is isomorphism into SOD plus 1, 1. So now this is just some details, and finally we can fix the 3-point function into these box spaces. So this box spaces, okay, so I will quickly explain this. So this box spaces contains N, V, and H. So this means that even for 3 spinning primary operators, the 3-point function can still be fixed. So now we can explain, we can use this differential basis to change the box spaces. So finally, we can use these 4 differential operators to get the spinning conformal blocks. So now this is all done with at the CFT side. So the second part is the Witten diagrams. So in ADS D+1 CFT correspondence, we know the CFT correlation functions can be mapped to Witten diagrams. So this Witten diagrams is similar to the Feynman diagram. So it's like there are 3 propagators, and the circle it means the boundary. Because in the flat space we don't have boundary, but now in the ADS space it has a boundary. So this is much the same as the QFT. We just write some interactions. For example, there are 2 scalars and one with a spin. So now this is one interactions, like you saturate this covariant derivative act on the second scalar. And now this is just the form of propagators. So the result is we can see we use the ADS isometry can fix the 3-point functions into these box spaces. So we already know the answer, but so the ingredient we need to compute is this B factor. So this B factor contains the many gamma functions. But this gamma function, but the pole of gamma function will capture the physical double trace and a single trace. So for spinning, we have the same way. We can still write a different kind of interactions. So this T and W just the index. So, but we know the result can be interpreted as the conformal basis we know. So now the first ingredient is we can split 4-point Witten diagram into geodesic Witten diagrams. Use the split representation. So now the split representation can cut the middle line of the propagators into two propagators connected boundary. So result, this is just some equations we use, and this is some meromorphic functions in these propagators. So now we study the cut 3-point functions. This left and right part, these are 3-point functions, and then we calculate these 3-point functions, and we know the result is still the same because we know the conformal basis. We know the conformal symmetry will fix the form of the 3-point functions. So the main ingredient is the same. We calculate these big B factors, and the final result is that big factors can be connected like this way. So now you can see that contains a single trace part and a double trace part. So now it means that we can decompose this 4-point Witten diagram into geodesic Witten diagrams. So now in Perkrau's paper in 2015, they can prove the geodesic Witten diagrams will compute conformal blocks. But in our papers, we have the alternative way to prove it. We just use the same split representations and cut the middle propagators into 2 propagators connecting to the boundary, and then we compute these diagrams. I don't show the detail, but in our paper we show the detail to compute this. So use this way, we can first prove the geodesic Witten diagrams will be the conformal blocks, and compare these 2 big factors. The gamma factors can show the physical of the single trace and double trace operators. So this is the first achievement in our paper. Yeah, so this is just some detail. So finally, we move to the spinning case. It means that in the ADS space, we have different spins. So first, we just consider scalar, but now we have the 3 spins. So there are more different interactions we can write because you have arbitrary spin interactions. So and we compute this geodesic diagram means that we integral not just the entire space, but integral along the geodesic connecting P1 and P2. So we can prove these results like this. So now the result, this Q can be is the transverse polynomial in Z. So finally, we can show that this Q is a combination of the correct conformal symmetry in the 3-point functions. And so finally, we can just use the previous way of connecting these box spaces into use some differential operators only act on the P1 and P2 to change it to the external basis. So use this way, we can prove the spinning geodesic Witten diagrams will be the spinning conformal box. So, but little detail is I didn't show it here is you have to modify the interactions because you integrate along the geodesic, but not the entire space. So this is our final result. We can prove the spinning geodesic Witten diagrams actually calculate the spinning conformal blocks. Okay. Thank you.
Thank you. So, any questions? No? What is the